Top 25 Software Engineering Interview Questions and Answers. Software engineering interviews are designed to evaluate both technical expertise and problem-solving ability. Employers assess your understanding of programming fundamentals, system design, algorithms, data structures, and software development methodologies. Beyond coding skills, interviewers also examine communication, teamwork, debugging ability, and how you approach real-world challenges. Preparing for common software engineering interview questions can significantly boost your confidence and performance. In this guide, you'll find the top 25 software engineering interview questions and answers, each explained clearly and concisely to help you succeed in technical and HR interview rounds. 1. What is software engineering? Software engineering is the systematic application of engineering principles to design, develop, test, deploy, and maintain software systems. It focuses on creating reliable, scalable, and maintainable solutions using structured methodologies. Unlike simple programming, software engineering involves requirements gathering, system architecture, documentation, testing strategies, and long-term maintenance planning. It ensures that software meets quality standards, performs efficiently, and satisfies user requirements. By following best practices and development models, software engineering reduces risks, improves productivity, and ensures successful project delivery within time and budget constraints. 2. What is SDLC? SDLC stands for Software Development Lifecycle. It is a structured process used to develop high-quality software in a systematic manner. The SDLC includes phases such as requirement analysis, planning, design, implementation, testing, deployment, and maintenance. Each phase has specific deliverables and goals. Following SDLC ensures that the project progresses smoothly and meets stakeholder expectations. It helps teams manage time, cost, and resources effectively. Different SDLC models, like Waterfall and Agile, offer various approaches depending on project complexity and flexibility requirements. 3. What are the different SDLC models? There are several SDLC models used in software development. The waterfall model follows a sequential approach where each phase must be completed before moving to the next. Agile promotes iterative development and collaboration with frequent feedback. The spiral model combines iterative development with risk analysis. The V model emphasizes verification and validation at each stage. The incremental model delivers software in small functional pieces. Each model has advantages and is selected based on project size, complexity, risk factors, and customer involvement. 4. What is Agile methodology? Agile is an iterative and flexible software development methodology focused on collaboration, customer feedback, and rapid delivery. Instead of completing the entire project at once, Agile divides work into small increments called sprints. Teams continuously test, review, and improve the product. Agile promotes adaptability to changing requirements and encourages close communication among stakeholders. Frameworks like Scrum and Kanban follow Agile principles. It improves customer satisfaction by delivering working software quickly and responding effectively to change throughout the project lifecycle. 5. What is Object-Oriented Programming, OOP? Object-Oriented Programming is a programming paradigm based on objects and classes. It focuses on 4 main principles: encapsulation, abstraction, inheritance, and polymorphism. OOP organizes code into reusable components, making it easier to maintain and scale applications. Encapsulation protects data. Abstraction hides complex implementation details. Inheritance promotes code reuse, and polymorphism allows flexibility in behavior. Languages like Java, C++, and Python support OOP concepts. This approach improves code structure, reduces duplication, and enhances overall software quality. 6. What is the difference between abstract class and interface? An abstract class can contain both abstract methods and concrete methods with implementation. It allows partial abstraction and can maintain state through variables. An interface, however, primarily defines method signatures without implementation, ensuring full abstraction. A class can implement multiple interfaces but inherit from only one abstract class in most languages. Interfaces promote multiple inheritance of behavior, while abstract classes are useful when classes share common functionality. The choice depends on design requirements and intended flexibility. 7. What is encapsulation? Encapsulation is an OOP principle that bundles data and methods within a class while restricting direct access to certain details. It protects internal object states from unauthorized modification. By using access modifiers like private, protected, and public, developers control data visibility. Encapsulation ensures data integrity and security by allowing changes only through controlled methods. This improves maintainability and flexibility, as internal implementations can change without affecting external code. It is fundamental to writing secure and well-structured object-oriented programs. 8. What is polymorphism? Polymorphism allows objects to take multiple forms, enabling one interface to represent different underlying implementations. It is achieved through method overloading, compile-time polymorphism, and method overriding, runtime polymorphism. Polymorphism increases flexibility and scalability in software design. For example, a base class reference can point to derived class objects, allowing dynamic method execution. This promotes code reuse and simplifies maintenance. Polymorphism is a key OOP concept that enhances extensibility and supports loosely coupled architectures. 9. What is inheritance? Inheritance is an OOP concept where one class acquires properties and behaviors of another class. The child class extends the parent class, promoting code reuse and logical hierarchy. It allows developers to build upon existing functionality without rewriting code. Inheritance supports method overriding, enabling customized behavior in derived classes. While powerful, it should be used carefully to avoid tight coupling and complexity. Proper design ensures better maintainability and scalability of applications. 10. What is abstraction? Abstraction hides complex implementation details and exposes only essential features to users. It simplifies interaction with objects by focusing on what they do rather than how they do it. Abstraction is achieved through abstract classes and interfaces. This concept reduces system complexity and enhances code readability. By separating implementation from interface, abstraction supports modular programming and easier maintenance. It enables developers to make changes internally without affecting the overall system functionality. 11. What are data structures? Data structures are ways of organizing and storing data to enable efficient access and modification. Common data structures include arrays, linked lists, stacks, queues, trees, graphs, and hash tables. Choosing the right data structure improves performance and scalability. For example, hash tables provide fast lookups, while trees support hierarchical data representation. Understanding data structures is essential for optimizing algorithms and solving complex problems efficiently in software engineering. 12. What is a database index? A database index is a data structure that improves the speed of data retrieval operations on a database table. It works like a book index, allowing quick access to specific records without scanning the entire table. Indexes enhance query performance, but require additional storage and maintenance during updates. While they speed up select operations, excessive indexing can slow down insert and update operations. Proper indexing strategy balances performance and storage efficiency. 13. What is normalization? Normalization is the process of organizing database tables to reduce redundancy and improve data integrity. It involves dividing large tables into smaller related tables and defining relationships between them. Normal forms, such as 1 nanofarad, 2 nanofarads, and 3 nanofarads, ensure structure design. Normalization eliminates duplicate data and prevents anomalies during insertion, deletion, or updates. It improves consistency and efficiency in relational databases. However, sometimes controlled denormalization is used for performance optimization. 14. What is REST API? REST API stands for Representational State Transfer Application Programming Interface. It is a web service architecture that uses HTTP methods like GET, POST, PUT, and DELETE for communication. REST is stateless, meaning each request contains all necessary information. It typically uses JSON for data exchange. REST APIs are scalable, lightweight, and easy to integrate with web and mobile applications. They follow standard conventions, making them widely adopted in modern software systems. 15. What is version control? Version control is a system that tracks changes in source code over time. It allows multiple developers to collaborate efficiently without overriding each other's work. Tools like Git enable branching, merging, and maintaining project history. Version control improves team productivity, ensures code backup, and simplifies debugging by tracking previous versions. It supports collaborative development and continuous integration. Proper version control practices are essential in professional software engineering environments. 16. What is Git? Git is a distributed version control system used to track changes in source code during software development. It allows multiple developers to work simultaneously without conflict. Git supports branching and merging, enabling experimentation without affecting the main project. It maintains a complete history of changes, making it easier to track bugs and revert to previous versions. Platforms like GitHub and GitLab use Git for collaboration. Git improves productivity, transparency, and team coordination in modern development workflows. 17. What is CI/CD? CI/CD stands for Continuous Integration and Continuous Deployment or Delivery. Continuous integration involves automatically merging and testing code changes frequently to detect issues early. Continuous deployment automates the release of tested code to production environments. This practice reduces manual errors, accelerates development cycles, and ensures consistent software quality. CI/CD pipelines use automation tools to build, test, and deploy applications efficiently. It promotes faster feedback, improved collaboration, and reliable software delivery. 18. What is unit testing? Unit testing is a software testing technique where individual components or functions are tested independently to ensure they work correctly. Developers write test cases to validate logic, inputs, and outputs. Tools like JUnit and IngUnit help automate testing. Unit testing improves code reliability and makes refactoring safer. It helps detect bugs early in development, reducing overall costs. Writing comprehensive unit tests ensures higher code quality and supports continuous integration practices. 19. What is multithreading? Multithreading is a programming technique that allows multiple threads to execute concurrently within a single process. It improves performance by utilizing CPU resources efficiently. Threads share memory space, enabling faster communication compared to separate processes. Multithreading is useful in applications requiring parallel tasks, such as web servers or gaming systems. However, it requires careful synchronization to avoid issues like race conditions and deadlocks. Proper thread management ensures stable and efficient applications. 20. What is a deadlock? A deadlock occurs when two or more processes or threads are blocked because each is waiting for resources held by the others. This results in a standstill where no process can proceed. Deadlocks typically occur due to mutual exclusion, hold and wait, no preemption, and circular wait conditions. Preventing deadlocks involves resource allocation strategies, proper synchronization, and avoiding circular dependencies. Detecting and resolving deadlocks is crucial for maintaining system stability and performance. 21. What is scalability? Scalability refers to a system's ability to handle increasing workload by adding resources without compromising performance. It can be vertical scaling, adding more power to a single machine, or horizontal scaling, adding more machines. Scalable systems maintain efficiency under high traffic or large data volumes. Designing scalable software involves load balancing, caching, and distributed architecture. Scalability is essential for modern applications, especially cloud-based platforms, ensuring consistent user experience as demand grows. 22. What is cloud computing? Cloud computing is the delivery of computing services such as servers, storage, databases, networking, and software over the internet. It eliminates the need for on-premises infrastructure. Cloud models include IaaS, PaaS, and SaaS. Providers like AWS, Azure, and Google Cloud offer scalable and cost-effective solutions. Cloud computing enhances flexibility, disaster recovery, and collaboration. It allows businesses to scale resources on demand and pay only for what they use. 23. What is microservices architecture? Microservices architecture is a design approach where an application is divided into small, independent services that communicate through APIs. Each service focuses on a specific business function and can be developed, deployed, and scaled independently. This architecture improves flexibility, fault isolation, and faster development cycles. However, it requires efficient communication and monitoring. Microservices are commonly used in large-scale systems where scalability and agility are essential for growth. 24. What is design pattern? A design pattern is a reusable solution to common software design problems. It provides proven templates to improve code structure and maintainability. Design patterns are categorized into creational, structural, and behavioral types. Examples include singleton, factory, observer, and MVC. Using design patterns promotes best practices and standardization. They help developers solve recurring issues efficiently without reinventing solutions. Proper understanding of design patterns enhances system architecture and long-term maintainability. 25. What is system design? System design involves defining the architecture, components, modules, interfaces, and data flow of a system to meet specified requirements. It focuses on scalability, reliability, performance, and security. System design includes high-level design and low-level design stages. Engineers consider databases, APIs, load balancing, caching, and fault tolerance. Effective system design ensures the application can handle real-world demands efficiently. It is a critical skill for senior software engineering roles and large-scale application development. Preparing for software engineering interviews requires both theoretical knowledge and practical problem-solving skills. Understanding fundamental concepts like SDLC, OOP, data structures, system design, and cloud computing gives you a strong foundation. Employers value candidates who can explain concepts clearly and apply them to real-world scenarios. Practice coding regularly, work on projects, and review common interview questions to build confidence. With consistent preparation and a clear understanding of core principles, you can significantly improve your chances of securing a software engineering role.